Ted, and thanks everyone. Particularly happy to present this work here at BITSS because the project was funded by a BITSS grant more years ago than I care to admit. Okay, so I'm going to try to go through this quickly because there's a bunch to cover. So, as nobody in this room needs to be reminded, pre-analysis plans have been championed as a really important tool for trying to increase the credibility of research, largely for two reasons. One is because they can prevent phishing, that's what I'll call it, or it's p-hacking, or data dredging. And also they prevent or can reduce harking, hypothesizing after you see your results. Our project is motivated by the question of are PAPs actually achieving these goals in practice? We've got good theoretical reason to think that pre-specification could help achieve these goals, but are they in practice? Of course, this is a really hard question to answer. We don't randomly assign to researchers whether or not they file a PAP. Researchers select into it. In fact, researchers across the many projects that they may be working on at a given time select into which ones they choose to pre-register and which ones they don't. And furthermore, absent a PAP, we can't assess whether a finished project has diverged from something that was pre-specified because what was pre-specified wasn't actually written down. So we adopt a different approach. We draw a representative sample of around 200 pre-analysis plans from the AEA and EGAP registries. We analyze their contents to see whether they are, in our judgment, sufficiently clear, precise, and comprehensive to meaningfully reduce the scope for phishing and harking. And among the subset of PAPs, about half in our sample, that were selected to actually have a publicly available paper, we also scrutinize and compare the paper and the PAP to be able to render an assessment about whether or not the paper is faithful to what was pre-specified. These judgments that we make are necessarily subjective. I want to be clear about that. Our analysis is not causal. I also want to be clear about that. But we believe the analysis is still illuminating because it's the best way we know of to get at this question of whether PAPs, as they're actually written and as they're actually used, are holding promise of achieving the goals that everybody invokes when they talk about why we should all do them. Okay. What motivates this stock taking? It was a lot of effort. Well, part of the motivation was that it's really costly to write and to follow a PAP. And so we want to know whether it does any good, whether there's anything on one side of the balance sheet to justify the costs on the other side. So writing a PAP is hugely time consuming. In addition to the coding we did a survey of PAP users from the IPA and EGAP member lists. I'll describe that a little bit in a minute. But one of the questions we asked was, how long does it take you to draft a PAP for a typical project? And the median response was 2 to 4 weeks. 28% of respondents said more than a month. 30% said about a week. So the point is there's a tremendous time expenditure, and we want to know whether it's worth it. Okay? Beyond the time that PAPs take to write, PAPs are also claimed to generate a bunch of other problems. So it's claimed that they limit the scope for breakthroughs that come from unexpected surprise findings, from just mucking around in one's data and seeing what one finds. It's claimed that they force researchers to undertake analyses that once they've looked at the data, they realize were boneheaded and ill-advised. And it's been claimed that PAPs generate boring lab-like papers that reviewers and editors don't favor. And so to adopt a PAP and to be faithful to it might actually handicap you in the review process and undermine a lot of the professional rewards that come from your research. In addition, critics point out that all the pre-registration in the world, even if PAPs in principle could work, aren't going to do any good unless there is a very strong policing regime, and that there are not very strong incentives in the discipline for people to actually police to make sure, and it's hard work, that what's published accords faithfully with what was pre-registered. Okay? So in sum, PAPs provide, in theory at least, very big benefits, but they also entail real costs, at least allegedly. And so the stock taking that I'm going to present was aimed at trying to assess where we fall in this balance sheet. Okay. So we drew a representative sample of PAPs from studies, as I said, registered on the AEA and EGAP registries. In all, we looked at 195 PAPs, 102 without papers, 93 with papers. All PAPs were coded according to a common rubric. by at least 2 coders, and anytime there was a discrepancy, we went back and recoded and tried to reconcile the discrepant codings. Additionally, we coded, as I said, a subsample of PAPs that had publicly available papers with an eye towards judging whether the paper stayed faithful to what was pre-specified. We did a survey of PAP users, sent to all EGAP and IPA affiliates. So we reached out to 664 people. We got responses from 155. That is not it's a pretty good response rate. It is obviously not random, so keep that in mind when I show you the results, but we think it's informative. We also have recently done an analysis of publication outcomes of NBER working papers that do and don't include pre-analysis plans to try to get a handle on whether writing a pre-analysis plan actually handicaps you downstream when you try to get your paper published. Okay, so first of all, do PAPs reduce the scope for phishing? Well, what makes phishing possible? Phishing is made possible by imprecise variable definitions and lack of clarity about all the details of the analysis that you're going to undertake. And if you are unclear about all those details, then it allows you, the researcher, either nefariously or sometimes just inadvertently, to present as your test of the key hypothesis of interest the particular specification that happened to generate what you judge to be the most attractive set of findings that you want to present to the world. Okay? In our coding, we found that 70, and I'm going to present all these figures without judgment, just the facts, and we can then discuss what to make of them. In our coding, 77% of primary dependent variables and 93% of primary independent or treatment variables were judged to have been clearly specified. PAP authors, however, were much less good at specifying the control variables that they would include in their analysis. In 44% of PAPs, it just was not possible for us to count clearly the number of control variables that were going to be included ultimately in the analysis. There's a very nice recent paper I just stumbled on by Gabe Lentz and Alexander Son here at Berkeley that do a bunch of nice simulations showing how much lack of specificity in the covariates that you're going to include in your analysis, how much the lack of specificity provides scope for phishing post hoc downstream, and it's quite striking. 68% of PAPs we determined had clearly specified the precise statistical model that would be run. 37%, I'll say only 37%, specified how they would estimate standard errors. In 19% of the cases, the model presented in the paper differed from the one that was pre-specified in the pre-analysis plan. And deviations, I should make clear, are not a problem. You just have to be transparent about them and provide an explanation for why you deviated. What was somewhat shocking and upsetting was that only in one case, in this 19% that deviated, was that deviation even mentioned in the paper. Then there's a whole host of other things we coded that are informative about other aspects of the design. 25% of PAPs specified how they would deal with missing values or attrition. 8% specified how they would deal with outliers. 20% specified how they would deal with imbalances. Those kinds of pre-specified characteristics are more or less important for different kinds of papers, so we don't put too much into that. It's still informative. But the bottom line is that these PAPs leave lots of latitude for, in many studies at least, for researchers to tweak their analyses in a way that generate particular results. Okay? What about harking? Harking is made possible through a lack of clarity about the specific hypothesis that you're trying to test. And what it allows you to do, if you're not clear about what it is you're going to do, is downstream you can just move the goalposts and recharacterize the goals of the research to be studying some other outcome on which you happen to have had significant, interesting results, and away from the outcome that motivated the research in the first instance. 90% of PAPs in our sample were judged to have specified a clear hypothesis. However, scope for harking can also come from specifying too many hypotheses. An interesting fact that we stumbled on, or recognition that I stumbled on, is that the problem, greater scope for phishing comes from too little specification, greater scope for harking comes from too much specification. And many of the PAPs that we studied had too much specification in terms of hypotheses. 34% of the PAPs we looked at pre-specified between 1 and 5 hypotheses, which George and I take to be sort of a reasonable number that you can, that leaves only limited leeway for post hoc selecting particular hypotheses to emphasize in your write-up. But many PAPs specified more. So you see the 34% of PAPs that specified 1 to 5 hypotheses, but 18% specified 6 to 10, another 18%, these are rounded, specified 11 to 20, and 8% specified more than 50 hypotheses. Okay? Now, one safeguard against specifying too many hypotheses in advance is to distinguish between those that are primary and those that are secondary. That's totally kosher. However, even then, many PAPs pre-specify so many primary hypotheses that this distinction between primary and secondary loses the help that it might have otherwise provided. So this is a histogram of PAPs that pre-specified more than 5 hypotheses and distinguished between primary and secondary. And you can see that a very large share still pre-specify many, many primary hypotheses. So another safeguard, of course, if you're pre-specifying lots of hypotheses, is to just commit to doing a multiple testing adjustment. Among the PAPs that pre-specified more than 5 hypotheses, just 28% committed in advance to doing a multiple testing adjustment. But the real question is, do authors take advantage of this latitude in practice? So what we found is that authors faithfully presented the results of all of their pre-registered primary hypotheses in 61% of cases. In more than a third of cases, the papers had at least one pre-registered hypothesis that was never even reported. And the median paper neglected to report 25% of the total hypotheses that had been pre-registered in the pre-analysis plan. And notably, 18% of papers presented totally novel hypotheses that were not even mentioned in the pre-analysis plan. And again, that would be fine so long as that's labeled, but in 82% of cases, those new hypotheses were not identified in the paper as not having been originally pre-specified. So, is the glass half full? Is the glass half empty? I didn't put more than one qualifier on the percentages I gave you. So our judgment is, PAPs are often not written and used in a way that allows them to do everything that their proponents had hoped that they might be able to do. As we've shown, many PAPs are insufficiently clear in the hypotheses they pre-specify so as to really rule out harking. The details provided in many PAPs are insufficiently precise and clear so as to prevent phishing and p-hacking. And papers don't always follow their PAPs. And deviations, even more importantly, are not always faithfully reported. However, that's the glass is half empty side. The glass is half full view is that, roughly half of the PAPs that we analyzed, if you identify, I'll do it here. If you identify what we take to be the 4 key requirements of a complete PAP, you clearly pre-specify the hypothesis that you're investigating. You clearly specify your dependent variable in a way that prevents post hoc adjustment. You clearly pre-specify your main independent variables in a way that prevents post hoc adjustment. And you clearly specify the statistical model you're going to run to test it all. This is the histogram reporting the share of PAPs that did all 4, 3, 2, 1, and none of those things. So the good news is 50% of PAPs did all 4 of those crucial things. Another 34% did 3 of the 4, right? So we're up to 84%, roughly, of PAPs who at least did 3 of the 4. So maybe the record isn't that terrible. It's hardly perfect, but the point I think we want to make, and we'd love to hear your thoughts on this, is that even if the scope for phishing and harking isn't foreclosed by every PAP, these opportunities are limited to at least some degree in most, right? An imperfect PAP is better than no PAP at all. And an imperfect PAP increases the credibility of a research study, we think, over not having a PAP at all. But our findings do suggest that insofar as pre-registering one's hypotheses and even going the extra mile and writing a formal pre-analysis plan is taken as a signal that you're a credible researcher who's committed to getting it right, that signal might be noisier than we in the literature have thought that it might be. So our stock taking was mainly designed to assess this one side of the ledger, are PAPs doing everything that we assumed that they would be doing? But the data we collected, which I don't have time to get into, also allows us to address some of the questions that have been raised about the downside of doing pre-analysis plans. And you can look through the paper to see some of these things. I just want to come to one thing at the end. PAPs, again, are not doing everything their proponents had hoped. That was a tease for the paper. But we think they still do offer benefits for research credibility. And the objections to PAPs, which I didn't have time to talk about, things like they stifle creativity, they generate boring papers, we think appear to be somewhat overblown. But the thing to remember is that PAPs are really still in their infancy. We didn't have pre-analysis plans, as Ted said at the beginning of today's session, until like 2012, right? The other thing is our data only goes up through 2016. And so we can't rule out that we picked up the bad early, the teenage years, when PAP users were writing their first PAPs and still trying to figure out what to do. So it's possible that pre-analysis plans in today's sample are better. We think there are also arguments to suggest why they could be less good, because they just could be. But the point I want to end on is that improving pre-analysis plan adoption and improving the effectiveness of pre-analysis plans is going to depend on more than just whether everybody gets all 4 of those criteria in that histogram right. It's also going to depend on the development of a set of complementary norms and institutions in the social sciences, and specifically in political science and economics, because that's the focus of this paper more narrowly. So 1, we really need to have clearer guidelines and common guidelines about what PAPs should contain. There's a lot of new publications like the Christensen, Miguel and Freeze book that provides a couple pages of guidelines. There's a bunch of other things that do. EGAP has a 10 things to know about pre-analysis plans that's helpful. But nobody has come out in a discipline-wide fashion, to our knowledge, to say this is what you need to do. And so that could be a reason why some PAPs fall short. Second, we need to have clearer norms about how pre-analysis plans are used in the review process. There's a whole host of questions around that. And to the extent that there's going to be policing, which is to say, to the extent that the transparency that PAPs provide is taken advantage of fully, the logical place for that to happen is in the review process, but we lack norms about what reviewers' obligations should be, what editors should do, so we need to innovate on that dimension. Third, and this came up in the last panel to some degree, we need there to be institutions formed, whether it's gatekeepers or third-party actors, who can do things like certify that authors who are working with observational data didn't have access to the data before they wrote their PAP, or who can police the access that authors of studies have to their data in instances when they submit a pre-analysis plan that calls for iteration during the course of the research. What's ironic is that the innovation that many people have embraced to try to deal with the rigidity of pre-analysis plans, which is you file an iterative PAP, that's a solution on one dimension, but it raises a problem on another dimension, which is how do you police deviations from a complex, time-stamped, iterative pre-analysis plan? There's a recent paper by Rachel Glenister, Kelly Bidwell, and Kate Casey that grapples with precisely that issue. And then third, we would suggest that norms about presenting pre-analysis plans in lieu of finished research papers at department seminars needs to be generated, because to the extent that that becomes the norm, that comes to be seen as something that we all should be doing, then the incentives for people to file a PAP in the first instance so that they can take advantage of the kind of really awesome feedback you can get at an early stage in your project from presenting a PAP to an audience is going to have a virtuous effect on encouraging people to file more PAPs and in getting more out of the PAPs that are already filed. So I'll stop there. Oh, sorry. Yeah.
My bad, I was in the back. Sean Grant, Indiana University, great talk, really interesting study. For the point about common guidelines, I wonder if you've seen stuff from the clinical medicine literature, particularly the SPIRIT guidelines for developing protocols, and then there was a companion piece in JAMA in 2017 by Gamble et al. That's specifically about statistical analysis plans that I think match pre-analysis plans? And if so, how commensurate is that with the kinds of needs in political science and econ?
Yes, so I think those fields that you've mentioned are far ahead of the other social science fields like political science and econ in terms of having codified, disciplinary, sanctioned guidelines for what should be included in pre-analysis plans. There's a lot of good ideas out there. There's a lot of proposals, but there's no set of formally sanctified set of guidelines. And we can debate whether or not there should be, because what should be in a pre-analysis plan varies with the nature of the project. But to my knowledge, there isn't something analogous to that in political science and economics. And that could be part of the reason why we get such heterogeneity in what pre-analysis plans actually contain.
Thanks again.
Thanks.
Next up, we have Jessica Spybrook, who's a professor of evaluation, measurement, and research at Western Michigan University. And she's going to talk about the Registry for Efficacy and Effectiveness Studies.
I'll let you find it for me, maybe. Oh, that's not me.
Sorry.
I don't think I do very good with that one. Great. All right. Thank you. Thank you. And thank you so much for the opportunity to share what we're doing today. So I come from the field of education research, and I'm excited to kind of share with you where we're at in terms of thinking about registration and pre-analysis plans, and hopefully generate some feedback as in many ways your field and your disciplines are several years in front of us. So the purpose of my talk here is really to introduce you to what we're calling REES, which is the Registry of Efficacy and Effectiveness Studies. And I want to do that by kind of going through four things. So I want to tell you a little bit about why we developed REES specifically, our goals in the development of REES, kind of the key features and some of the things that we think make it a little bit different from some of the other registries that exist out there, and where we're at currently. So let me start a little bit by kind of giving you the background as to why we decided to do this within education. So about 5 years ago, the Institute of Education Sciences, which is the primary research body within the U.S. Department of Education, gave a grant to the Society for Research on Educational Effectiveness. And one of the goals was to get a registry underway, or to at least kind of survey the landscape and see if that was the best path to take. And so I actually took a leave and spent a year with SRE to try and help develop this and kind of see where we were at. And the first thing we started with was to say, okay, you know, we don't want to recreate something that already exists out there. And so is there an existing registry that is going to meet the needs of the education research community? Or is this something that we actually do want to start from scratch, in essence? And so to do that, we kind of thought of three criteria that really guided what we were looking for. And so the first criteria was that it had to include all pertinent designs. And so this registry is specifically about impact studies, or studies, you know, seeking to assess the impact of an intervention, a curriculum, a teacher professional development, whatever it may be. And so within education, we are pretty well guided by the What Works Clearinghouse, which assesses the quality of studies at the end. And there's guidelines in terms of the rating that you can get from the WWC. And so these mean a lot to folks because it has implications for future funding in many cases. And so according to the WWC, they will review 4 types of studies that are seeking, or kind of that fit into this impact study world. And so randomized trials, quasi-experimental designs, regression discontinuity designs, and single case designs. And so we were looking for something that was going to serve all 4 of these purposes. The second thing we were looking for is a relevant, targeted focus. So we wanted to have something where folks were going to say, okay, this is where I'm going to go to register my education impact study, and kind of start to build consensus around the place to look. And the third thing that we were looking for is we wanted it to be easy and efficient to use, because this is something that we're kind of introducing to the field. And so any of the barriers we can take away to get people to want to do this, we wanted to try and do that from the very beginning. So what this led us to, sorry if you can't see that very well in the back, is to kind of take a look at what existed at this point. And so we've heard a lot about the AEA registry today, and I'm so excited by how far along they are and all the things that you can look at, and can't wait till we get there one day. And the EGAP, we heard a little bit about that, or obviously about that one too. And this is kind of where we focused our attention, was to say, okay, are any of these kind of big registries that exist out there going to help us meet the needs of the ed research community based on that 3 criteria that I just listed? And so if you kind of go through this, we can see, the problem with AEA is it is focused on RCTs. And within ed, we need to be broader than that, because other types of work and type of designs really are commonly used. And so that kind of kicked that one out as a possibility. Many of the other ones were more open in terms of design, but then again, it was thinking about that targeted focus. So for example, EGAP has a very targeted focus, and it's great. So if you're in that field, you know where to go. It wasn't the focus that we were looking for. And so that kind of takes out RIDE and EGAP and kind of left us with OSF, and we did a lot of work looking through the different options that were there. And again, kind of what led us away from that direction was, looking for that targeted focus. And also, quite honestly, we had some trouble in terms of being able to figure out exactly what to do within there. And so there was some concern that it was going to be off-putting to folks in terms of trying to navigate that system. So ultimately, that led us to design our own registry, very much building on much of what we had seen in these other ones. So to let you know a little bit about our goals in development, so obviously, we were thinking about these 3 criteria, right? We wanted to do these things. And then we also had 4 kind of additional goals when we were developing REIS. So, we wanted to make sure that we were getting details related to the pre-analysis plan. So it wasn't, we didn't want to just collect that basic information, but we wanted to get our heads around and have people write down their pre-analysis plans. We also were very interested in trying to collect this data in a systematic way across studies. So trying to kind of introduce some common language to folks, and to kind of ensure some consistency of that language across the data that we were collecting. Part of this is kind of with the meta-analyst in mind, hey, we're talking about the same thing here. And so we tried to put some of that language in, as you'll see in a minute. And then the last thing that we tried to do was to maintain some consistency with the Wwc Standards. So as I said, the Wwc is a big guide for folks conducting education research. And so, we tried to use language that was consistent with the Wwc, kind of rules that are consistent there, so that ultimately the goal would be that, kind of the information in a registry entry can be linked up to the review that a Wwc will do at the end of a study. So those were kind of our goals, and they led to a specific set of features that we included while we were designing REIS. So just generally speaking, it's laid out in 8 different sections. And so the first 2 sections are kind of our basic study information here. And then in sections 3 and 7, we really get into the nitty-gritty of tell us what your plan is. So for example, the research questions, we have folks delineate between your confirmatory questions, your exploratory questions. And actually, we then just pursue additional information on their confirmatory questions. As you'll see in a minute, we ask very specific information about study design, and this is where we really try to get into using common language across entries. The other thing I would point out here, so in section 7, and I have a link in here for those of you who'd like to go and play around, you can see exactly the types of questions that we ask. We ask about analysis plans, and here including things like, do you plan to control for multiple comparisons? If so, how do you do this? So many of the same elements that Dan was talking about. So kind of the next very intentional design feature is that we tried to use categorical responses as much as possible. So as I mentioned in the study design, kind of under this WWC guise here, we have 4 specific types of designs that we were focused on in impact studies. And so we ask a person to actually select the appropriate design category. So one of the big reasons that we tried to use the categorical responses is simply in narrative form, people can talk about the same design in a very different way. And so I might say, oh, I'm doing a multi-site randomized trial. Oh, I'm doing a blocked experimental design. And in both cases, maybe folks are talking about the same thing, but it's not always immediately obvious to people. And so we really tried hard to standardize some of that language as much as we could. So we start with the categorical responses. And then, again, we also tried to use very domain-specific language in here. So we said, these are folks who are going to be registering education impact studies. So what are they talking about? Well, we know what they're talking about. They're talking about students who are within teachers. We have a lot of multi-level studies, clustered designs. So they're talking about schools, they're talking about districts. And, we know enough about the impact studies that are being done that we felt we could identify, for example, in this particular question, the potential unit of random assignment. Okay, so this is, after a person would say that they're doing a randomized trial, then they're going to be asked a host of questions with more specific details related to their randomized trial. And again, because we're in a pretty small domain, we actually can give most of the options that someone would see. So kind of the next feature that I think is a little bit different is one of the things that we tried to do was to ask relevant information. Because I know for myself, when I'm filling something out, and if it starts asking me about questions that are not at all related to what I'm doing, it can be a little bit frustrating. And so in the goal of streamlining things and also using common language, we have this, what I would call a design classification tree built into the system. And so you go through your series of questions about a study design, and based on your responses, your actual kind of more specific design classification is going to be noted here. And so it asks, hey, is this really what your design is? So for example, you answered a set of questions. It's going to say to you, oh, okay, you have a 2-level cluster randomized trial. And if you agree with that classification, then you would want to move forward from there. And if not, then something is kind of amiss in terms of your responses to the questions and what's going on underneath. So part of the reason that we built that tree, as I said, is so that we could ask specific questions. So for example, if a person says, yes, it is a 2-level CRT. We've already asked them about their unit of random assignment. We've asked them about their levels of nesting. And so we're going to specifically ask them then, tell me about how many kids you have in each of your schools. Tell me about how many schools are in the treatment and how many schools are in the comparison. So trying to use the language that they've already provided us about the particular units in their study. As you would expect, an entry is set up to chronicle changes, right? So, for example, what I have here is this is the PDF of a study that's currently up there. And so here's kind of the first version. We can see it was February 6th of 2019. And then the person went back in and made changes on August 28th. And so what we ask is we ask for not only changes to the actual entry itself, but for a brief narrative description of what those changes are so that somebody could quickly try and figure out what happened or why folks were updating. And so you can see kind of their description as well as on the top one here, this is their final version. But all of the versions are available. The most recent version is going to be the one that comes up first. So this was kind of our design. And so the question was, oh my gosh, are people actually going to do this? And starting to think about how do we do that? So one thing that has been helpful is that IES in their most recent RFA actually says to folks now, you need to pre-register your studies. So when you are funded, that's what needs to happen. Not really saying that that's a norm yet and that's happening, because I don't think that's the case, but we're starting to see some of the beginnings of that. So I will tell you kind of where we're at thus far. So we launched on Halloween, it should say 2018, not 2019. So we launched about a year ago. And we have 137 entries to date. So I was really excited about this. It kind of shows that we're starting to, get some traction, I would say, and kind of get people to have a sense of what we're doing and hopefully to start to develop some buy-in. Just to give you a sense of what we have in there, so I was just kind of looking through. One of the nice things about having these very specific fields is that I can go in really easily and try and figure out what folks are doing. And so of these 137 entries, 131 of them actually do specify the design category. So for me, that's the first start of saying, how much detail are you providing? Are you going through those questions about study design? Because you can't get to anything else until you do that. And so we can see most of the studies are at least getting that far, and the majority of the studies are randomized trials in here. And then more specifically, so I'm very interested in research design, and I want to know the types of designs that folks are doing. And so I just pulled within those 105 randomized trials and said, okay, what are the actual classifications of the designs that are being done? So you can see on here, so the lighter blue is a multi-site cluster randomized trial. So that would be a design in which we have districts, and then within districts, we might be randomly assigning schools to condition, and then we have students that are nested within those schools. And that's a really common design in ed research. But this just kind of gives you, a sense of what the designs look like within these randomized trials. So last thing, so this is actually a joint effort. So originally, SRI was, funded to do this work, and actually we've joined up with ICPSR at U of M, and they are going to be the host for the site. We'll be moving over there in the next couple of months. So the ultimate goal would be to start to leverage some of the other work that ICPSR does and kind of build this out into something a little bit larger with capacity around, data sharing and as we talked about yesterday, sharing results and things like that. All right.
Thank you, Jessica.
Yeah.
Do we have any clarifying questions for her?
All right.
Okay.
Thank
again.
you.
Next up, we have Eric Stromlund, who's an associate professor of economics at University of Oslo, of Bergen. I'm sorry.
So, first of all, thank you for having me here. This paper is joined with Amanda Kvarmen at the University of Bergen and Magnus Johannesson at the Stockholm School of Economics. So the question that we're asking here is, should we rely on meta-analysis to provide summary conclusions in the behavioral sciences? And the background for asking that question is twofold. So first of all, there has been an increased use, almost exponential increase in the use of meta-analysis across different sciences for the last 30 years. And second, typically researchers and funding bodies tend to place meta-analysis or quantitative systematic reviews at the top of the hierarchy of scientific evidence. But should they? As we know, in recent years, there have been a surge of replication studies in the different behavioral sciences, from psychology to economics and for the social sciences in general. And typically, just about half of the replications are successful. And one major part of the reason for why this happens is because original studies suffer from publication bias and selective reporting of significant findings. And as a meta-analysis will rely on these original studies, biases in the original studies will affect the meta-analytic summary conclusion. But it's unknown to which extent these biases in the original studies will affect the overall conclusions provided by a meta-analysis. In the open science community, there are sort of two positions on the role of meta-analysis. And the first position is that meta-analysis is a net good. Increased reliance on meta-analysis will add to the credibility of the behavioral sciences. And there are several advantages to doing a meta-analysis. First, you're relying on a total body of evidence instead of just a single study. And also doing a meta-analysis means that you will have much more statistical power, so will be much less likely to provide false negative findings. Also, ideally, a meta-analysis will rely on both published and unpublished evidence, and a well-conducted meta-analysis will tend to implement different adjustment methods aiming to reduce the influence of publication bias. So meta-analysis holds potentially the promise for cumulative science. An opposing view is taken by Simmons, Nelson, and Simonson, and their argument is basically that because a meta-analysis is only as good as the original studies comprising it, so suppose that you have just a few biased studies in the literature, then if you add those studies into a meta-analysis, your meta-analytic conclusions are much more likely to be biased or generate false positive findings than if you just look at the individual studies. So according to Simmons, Nelson, and Simonson, increased reliance on meta-analysis will lower the credibility of the behavioral sciences. So we offer an empirical approach to testing for the validity of meta-analysis as a method. So what we do is that we compare the results of meta-analysis in psychology to the results of pre-registered multiple lab replication experiments, which have the format that they have been accepted prior to the results being known, and they have been carried out at multiple laboratories. So that means that each replication estimate in our sample is itself a meta-analytic estimate. The idea is then that because of this format, these pre-registered experiments are, on average, free from publication bias and selective reporting bias. So they form a natural baseline against which we may compare the results produced by meta-analysis. And we do two things. So first we compare the reported meta-analytic results to the replication results. And we also, using the primary study level data, we test different adjustment methods aiming to reduce the influence of publication bias and how they compare to the replication results. And then we can test for the sort of the validity of these adjustment methods as well. So this is just a summary of our method. So we start by identifying these multiple lab replication experiments. We then search throughout the literature for meta-analysis on the same research question. We then match together this meta-analysis and the replications, which test the same substantive hypothesis, and we estimate the differences between the meta-analysis and the replication. So this is just one example of this kind of registered replication report, here exemplified by the ego depletion replication. I don't have time to go into details of how we constructed our analysis sample, but we started out with 62 replication effects. We then searched the literature for meta-analysis that studied the same question, and we ended up with 39 meta-analyses. And we then assessed them further for eligibility and had to exclude 21 due to lack of correspondence and 2 because the data were missing. And we ended up with a final sample of 15 registered replication experiments and 15 corresponding meta-analyses studying the same research question. And for the analysis, we both test for the pairwise differences for each meta-replication pair. So whether for each pair, the meta-analysis provides a different conclusion than a replication. And also we estimate a meta-analytic model where we estimate the overall difference between the meta-analysis result and the replication result. And we follow Benjamin et al. And use the 0.5% significance level to label results as statistically significant, and we refer to findings significant at the 5% level as suggestive evidence against the null. So for the results, I'm first going to show you just a plot of the meta-analytic estimates and the replication estimates with corresponding 95% and 99.5% confidence intervals. So if you look at these results, you see that the meta-analytic estimate is typically in the same direction as the replication estimate. Also, almost always the meta-analytic estimate is much larger than the replication estimate. And this holds both for cases where the replication rejects the null and for cases where the replication fails to reject the null. And to provide sort of an idea of how large the overestimation is in a meta-analysis, on average, the meta-analytic average effect is about 3 times larger than the replication effect. So we would say then that the meta-analysis on average inflate the true effect with a factor of 3. When you look at the this is just showing that the differences tend to be statistically significant as well. And when we look at the meta-analytic effect, you see that this measure is also statistically significant and doesn't tend to vary with the way we define the sample. And it's also significant both for studies where the replication successfully replicated and for cases where the replication didn't replicate. We also look at whether the meta-analysis reduced the overestimation present in original studies by comparing effect sizes in original studies to the meta-analytic summary effect. And here we find that typically the meta-analytic estimate and the original study estimate are very similar, indicating that it doesn't seem like the meta-analysis are reducing the overestimation present in the original studies. One potential objection to the interpretation that we capture the degree of overestimation in the meta-analysis is that the meta-analysis typically consists of a variety of experimental designs, so there's a lot of heterogeneity, whereas the replication typically focuses on only a single design. And it could be that replicators systematically pick out designs for replication that they know or suspect are less likely to replicate. And that could potentially account for our findings, this kind of replicator selection or a kind of null hacking in a sense. We test for this mechanism by correlating a measure of heterogeneity in the meta-analysis with our meta-replication difference. The idea being that in literatures where there's a lot of heterogeneity, there is more scope for replicator selection. So then you should expect that if there is replicator selection, there is a positive correlation between the heterogeneity measure and our difference measure. But what we see is that not only there doesn't seem to be a correlation, but if anything, it's negative. So we don't find good evidence for this replicator selection mechanism. So what about adjustment methods? There is a variety of different adjustment methods proposed in the literature that all aim to mitigate or reduce the effect of publication bias. We don't test all of them, but we test 3 different methods and compare them to an unadjusted random effects result. And the first method that we use is a trim and fill, which is perhaps the most commonly used method. The second is the BITSS, which has been developed and recommended by Stanley and Doucoliagos, which is a sort of a regression-based test which estimates which runs a regression of the estimate on a standard error and a constant term, and takes the constant term as the unadjusted meta-analytic average. And finally, we test the 3-parameter selection model, which is a sort of more sophisticated selection model proposed by Hedges and Vevea, and also recommended recently in a review article and has been sort of shown in several simulation studies to have quite good performance. And now I'm going to show you a figure which is maybe not visible in the back. But the takeaway from this figure is that we compare the replication estimate to the meta-analytic estimate provided by all these different methods. And the main takeaway is that the random effects model typically tends to overestimate effect sizes a lot. And also, the estimated false positive rate for the random effects model is 100%, because in all cases where the replication fails to reject the null, the random effects model rejects it. So that then we say that the estimated false positive rate is 100%. But strikingly, this is also the case for both the trim and fill and the 3-parameter selection model. Both of these methods produce almost identical results to the unadjusted random effects model. And then there is the BITSS, which is this regression-based test. And this method does adjust effect sizes downwards. It tends to do that at least. But it also blows up the standard errors. So if you look at the yellow confidence interval, typically the BITSS means that the standard error explodes. This also means that even though the BITSS has a much lower false positive rate, and on average it hits the replication estimate, so that on average it has the same expected value as the replication, we also find that when the replication rejects the null, the BITSS typically fails to reject it. So that 3 out of 4 times when the replication rejects, the BITSS fails to reject. So then your trade-off is sort of between 2 or 3 methods which all have very high false positive rate and a method which has an extremely high false negative rate. So a sort of pessimistic summary from this talk is that, at least based on our sample of studies, meta-analysis in the behavioral sciences produce highly inflated effect sizes. They're extremely prone to producing false positive findings. They do not appear to reduce overestimation present in original studies. And commonly used adjustment methods that aim to reduce the influence of publication bias typically do not improve substantively the unadjusted meta-analytic results. So I believe that this suggests that purely statistical fixes to the ongoing reproducibility, credibility problems that we have in the behavioral sciences are unlikely to succeed. But it could be that in sort of a future climate where more research is pre-registered, that meta-analysis could start working better. I don't know. But back to this pyramid. So I'm a bit tempted to say that this pyramid should be flipped around, but I'm going to be more careful and say that at least we shouldn't put meta-analysis on sort of a prominent place compared to other methods, so instead I'll just flip this pyramid to the side. Thank you.
Thank you, Eric. Do we have any clarifying questions for Eric's presentation? And at the same time, I would like to invite Dan and Jessica to join us in this session.
Very interesting. Thank you. So I guess I'm still a little bit concerned about maybe extending these results to kind of all meta-analyses and the entire evidence pyramid. I think the way that you've looked at replicator selection is interesting, but I still worry that even if you had, let's say, a literature where there was no heterogeneity at all, it's still the sample of meta-analyses that get in here are ones that were chosen for replication. So I do still worry that, I mean, I think it's certainly a very interesting sample, but I worry that kind of extending this kind of skepticism towards all meta-analyses, I think worries me a little bit. My second question or concern with respect to heterogeneity is that I think when you're comparing when you're calculating the pooled standard error for the comparison, I think that doesn't incorporate heterogeneity, does it? It's just the standard error of the replication meta-analysis as well as the original, is that correct?
So there were, I think, 2 questions there. The first was sort of skepticism about if we can generalize from our sample of studies. I don't know. I would encourage others to replicate our methodology on an independent sample of studies. And that is possible. I mean, there are different other multiple lab replication experiments that have subsequently been published, which means that you can actually conduct sort of a good replication of our study for a different sample of studies. So I would encourage people to do that. For the other question, I was a bit unsure if I understood the question.
Yeah, so I was just curious, when you're directly comparing the pooled point estimate and your replications to that and the meta-analysis, I think if I caught it correctly on the slide, is it the case that you're calculating the standard error of that difference based on the sum of the variances of the replication and the meta-analysis, full stop?
Yeah, so we're assuming that the meta-analytic average and the replication is independent of each other, basically.
But you're also assuming no effect heterogeneity.
I'm not sure. It could be.
Okay.
I don't know.
I think we can open up the floor for questions for the other panelists as well. We have about 15 to 20 minutes.
Great presentations. I will follow up on the comparison of meta-analysis against the many labs. We're doing something very similar with Tom Stanley and Christo Kouliagos, and I see two differences in what we have done. I mean, probably we were dreaming of the same idea more or less, but one, you have found more meta-analysis than we have, and I'm wondering whether your criteria were a bit loose or lenient compared to ours, and most fields in these domains tend not to have meta-analysis. I'm a bit surprised that you found so many, unless you relaxed the criteria and allowed for some studies that are not exactly the same, but may still be reflecting somehow the multi-lab study that was multiply replicated. The second point is that BITSS is unlikely to do very well in that situation. I mean, you have mostly very small studies, so it's unlikely to correct, even though it might be the best looking method in terms of simulations. The best method that we found would be a weighted average of the adequately powered studies. And the problem here is that in most of these experiments, you don't even have adequately powered studies before you try to do the replication. So if that's the case, then I would say meta-analysis is still at the top of the pyramid if you have some constituent studies that are relatively well powered. Not necessarily 80%, it could be 40% or 50% to capture reasonable effects. But if you have the typical situation that is most of the cases that you showed, which is very small studies, then I wouldn't trust a meta-analysis. I think a significant result is far more likely to be false, even with a meta-analysis of multiple such studies, than to show something real.
I forgot the first question now. Sorry. Yeah, the looseness. Yeah, sure, it could be that we had a bit looser criteria. I don't know. For some of the subsample analysis, we restrict our analysis to only studies where the original study subjected to replication is included as a study. The exact estimate is included in the meta-analysis. And that reduces the sample. So it could be something like that. I don't know. So maybe we were a bit loose in the main sample. For the second, I fully accept your reservations. It's just a bit more fun to make some provocative statements.
I think this is maybe just a quick clarifying question for Dan. If I remember correctly, about half the papers, about half the pre-analysis plans had a paper published and half didn't. Was that just a function of time they had been out, or any static point in time you look like that's going to be the case? Or just sort of curious if there's differences along those lines. And then also, you mentioned covariate imbalances, whether people specified how they were going to deal with this. I'm curious how that relates to the time of writing the pre-analysis plan, because were any of these written after baseline, after you'd randomized? Because that, I wouldn't bother writing about how we didn't deal with it after we already didn't deal with it if we're writing the PAP later. So.
Right. So in the first question, it was not the case that 50% of pre-analysis plans have papers. We stratified on that criterion.
Okay.
Okay. And on the second point, that's a good point. We did not differentiate between PAPs that were filed after the data was collected and potentially some initial analysis, pre-analysis was done versus those that were specified. That's right. We did not analyze those subsets separately. In the paper, I think we report that the vast majority of pre-analysis plans were filed before authors had access to the data. But you're right. The deviations from the pre-specified notes about how you're going to deal with covariates carries a very different weight in those two different scenarios.
So my question's also about PAPs. First, a thought. So your concerns, Dan, about imperfections of PAPs, I think, are well placed. I just wanted to note that even the worst PAP helps us solve a problem that we had in the bad old days when researchers conducted inferential statistics that implied the claim that they had predicted exactly the result from exactly the test they report. Now we can tell whether that's exactly what they predicted. I wanted to invite you to comment on the complexity that arises from multiple hypotheses and the degree to which they should be adjusted, depending on whether the researcher behaves as if they're just going to report the one that comes out most significant or interesting versus report the entire suite of hypothesized and tested hypotheses.
Yeah, so I think some researchers will file PAPs as if they're hedging their bets, where they'll specify so many hypotheses that they hope one will come out, and then they can just focus on that one and say, hey, I pre-specified this hypothesis, while eliding the fact that they also pre-specified 7 others that didn't work out so well. So my view is that, and again, we are potentially looking at the early days of pre-registration. And one of the things that I think might show up in the data if we brought it more up to date is people learning, people pre-specifying fewer hypotheses. I will plead guilty to filing a PAP in the early days of our sample that was like 85 pages that pre-specified tons of hypotheses, right? I wouldn't do that today, right? So I think you have to be disciplined in the hypotheses that you pre-specify, because I think that on the back end, one is obligated either in the main text or in an appendix to report the results of everything that you pre-specified. So I think over time, as people learn how to use PAPs in a way that furthers not just openness, but good science, people will be more disciplined in the number they pre-specify. And because I think the recognition is the obligation is you have to report what happened with all of them.
I just wanted to kind of build on that very quick question, Dan, and thanks to all 3 of you for great talks. It's about the number of hypotheses again. So I just sort of had 2 points. One is when you presented the number of hypotheses, and even in the conversation now, you were saying, well, there's 10 or 15, like that's a lot of hypotheses, too many. And I was thinking, well, there's a lot of experiments with 3 or 4 arms, treatment arms, that have 4 or 5 main outcomes. That's totally sensible. It doesn't sound, outlandish to me. And then you'd have 20 main hypotheses. And so I thought, like, it's a little hard to know if 10 or 20 or whatnot is a lot, but, I could think of lots of experiments that were reasonably tight that had 4 arms and 5 main outcomes. And so I just wanted to make that point. The kind of broader point about the evolution of the field is something that we've, come up with, I think, a few times. And I think for all of us, I don't know if you have this data, but I think we'd all benefit if you even knew, is the PAP that you studied the first one that someone did? I don't know if that was in your survey or not. I see. Okay, but I mean, that would be the kind of like thinking about the learning curve would be interesting.
Yeah. I mean, I suppose we could go back through the registries, and for every PAP that we randomly selected into our sample, go back and see whether one or more of the authors had previously registered something, we could do that. And with respect to the other issue about, maybe 30 pre-specified hypotheses is not too many, sure. But I think somehow, either with a multiple testing adjustment, or somehow we all have to innovate and figure out ways to be able to write papers that aren't deathly boring, that actually present the full set of hypotheses that we pre-specified. Because the alternative is we sweep things under the rug and we're not being transparent about the process that generated the results that we're highlighting in our papers. And one of the things that's really come out of this is that, so in the PAP user survey, many people said, well, and it's an anonymous survey so people can vent, and they did. But many PAP users said, when you write a PAP, you wind up with just these boring papers, and I can't stand it, and you want to have something exciting and zippy. I just think we may have to acclimate ourselves to writing papers that, for the sake of better science, are just less snappy and zippy, right? We were saying earlier over coffee that there was a time a generation ago when people started putting regression results and being more self-conscious about their statistical modeling. And at the time, I'm sure there was pushback saying, oh, this gets in the way of the narrative and papers are just becoming science projects. And we got past that and it was accepted. And I think there may be another round of acceptance that will come to accommodate the need to stay faithful to what you pre-specify.
Hi, so I had a question in regards to secondary data sets and PAPs. So it's kind of similar to observational data, but how do we respect transparency when we're looking at secondary data sets, especially in light of the growing need that we should think about data sustainability and not necessarily relying on primary data collection in order to run studies? I wonder if any input and considerations you should think about when writing a PAP for that.
You want to take that?
Yeah, we haven't tackled that yet. We're just starting with the kind of prospective impact studies. But I will say that we have gotten some pushback from the field saying, hey, if you're doing this for one particular type of studies, we also need to think about something parallel for secondary data sets, for observational data. So I think that that's something we would like to see on the horizon. But it is more complex for the reasons that Cecilia talked about earlier today, and kind of thinking through how do we kind of monitor and assess in the same way.
So I wanted to ask a question about it's a comment that in the work that you did, Dan, with your co-author, you basically guys develop a way to critically appraise a pre-analysis plan, and have you guys thought about scaling that up? Do you have any statistics on how much time did it took to assess each of those? Is that something that could be recommended to reviewers, others?
Yeah, I don't have an average statistic. I can say that we got the grant probably someone in the room probably knows, 2013, 2014, 15 maybe. And we have a working paper now. Anyway. Okay. It takes a long time to do the analysis. We were doing almost 200 PAPs, so it takes a long time. Some are quite straightforward. By the way, the paper includes an appendix with the coding rubric, which you're free to scrutinize. Some are quite complicated and take a long time. I don't know, but one of the things, when I invoked at the end the norms that we need to try to adopt as disciplines, one of the norms is what should be expected of reviewers. Should reviewers be expected, if they receive a paper to review along with a pre-analysis plan that was registered before the project was actually written up, or when it was initiated, are they expected to go through the pre-analysis plan and to spend the time that we spent holding up the plan to the paper? I think the answer is probably yes. But I recognize that puts an enormous additional burden on reviewers who are, after all, volunteering their time for this professional service.
Okay. So this is just a quick question on the PAPs again. Sort of getting at what Ted was talking about, experience of those filing the PAPs. Did you consider looking at whether they were graduate students, junior faculty, tenured faculty, and how that affects the results you got?
Yes, so we excluded PAPs written by anyone who was not faculty or faculty equivalent. We excluded graduate students because we know that in some graduate seminars, students will be given assignments where they have to write a PAP. And we didn't think that if we were going to be trying to characterize the quality of pre-analysis plans in the discipline as a whole, that we would include graduate students who are very much still learning.
I think Matthew Rubin had I think it's on.
Okay. So this is probably very domain specific, and it won't help with the sort of formal statistical analysis you're doing. But one of the ways I look at studies is, could they possibly have had that as their main hypothesis and run that study? This is easier with sort of laboratory experiments and so forth. And so I don't know if there are any cases where it's just so obvious, and I don't know if there's any sort of like power tests you could do, that there would be alternative studies they would have done had that been their original hypothesis. And I also think there are some domains where you can run a study and it's so completely obvious what your hypothesis was. Again, this applies much more to the lab experiments, and that's a very good test of sort of believability of the hypothesis. So sort of pre-registration without any pre-registration.
Yeah. I mean, it's clear if you have one treatment in a laboratory experiment that you're randomizing across the subjects who come into the lab, then you almost don't need to write a pre-analysis plan. Except, imagine that you found a null result for the average student in the lab, and you thought, I wonder if it's different across men and women, or by whether or not the student has taken Intro to Economics or what have you, and you find something in some subset, that's a fishing expedition. And it seems it's important for the scholarly community to be able to distinguish between the product of a fishing expedition and the product of someone who, in their head going into it, hypothesized that women who had taken Intro to Econ would be different. And so that's the virtue even there. And the flip side is, if it's as simple as that, then writing the pre-analysis plan is trivially easy.
So I would say in our field too, a big area is with the outcome measures. So, you know, you're testing an intervention to improve reading achievement for kids, right? Well, you know, are you going to assess that using the state standardized reading test at the end of the year, or the researcher developed reading test? And so specifying that ahead and being really clear on what is the outcome measure that I'm going to use is a really important thing for us.